In this video, I am going to solve the problem 23rd from chapter 19. So here I am going to solve the subdivision J, K and L. The figure shows the cycle undergone by 2 mole of an ideal monoatomic gas. The temperatures are T1 equal to 300 Kelvin and T2 equal to 600 Kelvin and T3 equal to 455 Kelvin. And here, this time, we are going to find the answer for the heat transfer Q and change in internal energy of the gas and work done for the full cycle. So what is the full cycle here? The full cycle here is 1 to 2 is first state and 2 to 3 is the second state and 3 to 1 is the third state. Clear? So now what we are going to do, we are going to use the data from the previous videos, because in the previous videos I solved the answer for each state. For state 1 to 2 I made one video, and for state 2 to 3 I made one video, and also I made the video for state 3 to 1. So for this question you have to use the previous videos. But right now I have the answers for all the states, so I'm going to use the data for this question. If you want to get a more clear information, please see the previous videos. Okay. So now let's be start. So first of all, I'm going to find the answer for this. First of all, we have to calculate this Q. So for full cycle, we are going to find the value of Q. What is the value of Q? We have to add the value of Q from state 1 to 2, right? And plus state 2 to 3 and state 3 to 1. So better we can write what is the heat energy for the state 1 to 2. So the state 1 to 2, we got the heat energy value as 7.48 multiply 10 power 3 joules, and state 2 to 3 we got the heat energy as 0, and state 3 to 1 we got the heat energy as minus 6.440 10 power 3 joules. So as I already mentioned, for the clear information, because this time I'm going to use the data for the previous video, because previous video I made all the clear information for each state. So better when you just go for this question, better just to see the previous videos. Okay, then only you will get a clear idea. So for this video, I'm just only take the data. So now what I'm going to do, I'm going to substitute the value here. So what is this amount of heat energy for state 1 to 2? We got 7.48 multiply 10 power 3 plus state 2 to 3 is 0, and state 3 to 1 we got minus 6.440 multiply 10 power 3. So now when you just add all these, we will get the answer as 1040 joules. Clear? So this is the answer for our J part. Clear? Likewise, I'm going to use the data for change in internal energy for the previous video. So better I can give the answer here. So for clear information, so you have to go for the previous videos. Okay. So now I'm going to get the answer for the full cycle, because when you come for full cycles, you have to consider all the states. So in this question, if you see the diagram, the state mentioned 1 to 3, that means state 1 to 2, 2 to 3 and 3 to 1. So for that, we are going to find what is the change in internal energy. So which is our K part, right? So for K part, we are going to find what is the change in internal energy. So what I'm going to do, I'm going to add 1 to 2 plus 2 to 3 plus 3 to 1. Clear? Okay. Better I can give the answer for 1 to 2. So the change in internal energy for state 1 to 2, we got the answer as, I have to check the data. So we got the answer for the change in internal energy as 7.48 multiply 10 power 3 joules. Likewise, for the state 2 to 3, We got the answer as minus 3.614 multiply 10 power 3 joules. Okay, and state 321, we got the answer as minus 3.864 multiply 10 power 3 joules. Now what I'm going to do, I'm going to add all. So what is the answer for the change in internal energy for state 1 to 2? We got 7.48, right? So 7.48 multiply 10 power 3 plus, and state 2 to 3, we got negative of 3.614 multiply 10 power 3 plus, and the state 3, we got 3 to 1, we got negative of 3.864 multiply 10 power 3. So when you just add all these, we got the answer here as 2 joules. What is the answer here? We got the answer for the full cycle. The change in internal energy of the gas, the monatomic gas, here is 2 joules. Clear? Okay. Now we have to find the answer for L part, work done. Again, for L part, I have to take the answer from the previous data. So this time I have to add what is the work done from state 1 to 2 plus state 2 to 3, right? Plus state 3 to 1. So better I can give the answer. For state 1 to 2, we got the work done as 0. Work done equal to 0. And state 2 to 3, we got the work done here as 3.614 multiply 10 power 3 joules, and for state 3 to 1, the work done value here is minus 2.576 joules. Now I am going to add all this. So if you add all this, let's see what is the answer. For state 1 to 2, it's 0 work done. State 2 to 3, we got 3.614 multiply 10 power 3 plus, and state 3 to 1, we got the negative value minus 2.576. I think it's multiply 10 power 3. I forgot. Multiply 10 power 3. So if you add all these, for the full cycle, the work done is 1038 joules. So this is the answer for the last question. That's it. Thank you.